And last but not least, this one looks really nasty, does not actually end up being that bad. So I'm going to go ahead and start off by setting this thing equal to 0. You might feel totally like, I don't even know how to approach this. I'm just going to say we're in the factoring section. So let's go ahead and set it equal to 0 and see if we can get it factored. So I'm going to subtract that 10x squared from both sides. Notice that doesn't have a like term over here. I have a 6x to the 4th minus 28x cubed. Neither one of those has an x squared, so there's no combining it. You cannot add or subtract things that are not like terms. And like terms means that if they're fractions, they're the same size. If they have variables, they're the exact same variables with the exact same powers. We can't have anything different except the numbers out in front. Okay, so this still looks terrible. It doesn't look like the ones we were just doing. But let's go ahead and look for a greatest common factor. I think I'm seeing that each of those numbers is divisible by 2. And I also see that each of those has at least 2 factors of x in it. So remember, x to the 4th is x times x times x times x. So that's 4 factors of x. This one's 3 factors of x. And this one's 2 factors of x. So I should certainly be able to pull 2 out of all of them. That's going to leave some leftovers in those first 2 terms, not in the last term. So I'm going to remove a 2. I'm going to remove an x squared. Remember, you're dividing it out. So 6 divided by 2 is going to give me 3. If I divide 2 x's out of the 4 that I had, I'll have 2 left over, which will shorten back down to x squared to say that there's 2 factors of x. Next term, dividing isn't going to change the fact that it's negative. I'm dividing by positive 2, so half of 28 is 14. If I divide out 2 of those 3 x's, I'm going to be left with 1 of them. And then last term, dividing that 10 by the 2 is going to leave me with 5. If I divide out both of the x squareds, it's just going to leave me the 5 and nothing else. So this still might look scarier than before, but if you temporarily just ignore that 2x squared out in front, what's in the parentheses is now looking really similar to exactly what we were factoring before. So we're just not done yet. So we're going to try and unfoil. Just again, basically just ignoring that 2x squared out in front for now, working within those parentheses. I can split up the 3x squared into 3x and x. And then I have a 5 and a 1, and I get to decide which one's negative. To get that 14, I'm thinking I'm going to have to put the 5 out here because that'll give me 15x and then 1x in the middle. So if the 15 is negative and the 1 is positive, that will add up to negative 14. So this time I actually ended up with 3 meaningful factors. There's a variable in every single factor. So crucial thing is not ignoring that. That does actually contribute a solution. So we want to know, when is 2x squared equal to 0? When is 3x plus 1 equal to 0? And when is x minus 5 equal to 0? All 3 of those are possible. The 2x squared equals 0, you could think about that as x times x and split it up more, but I'm kind of hoping that just by inspection we're spotting that 0 squared is 0. When we multiply that 2 is still 0. So that's going to be true anytime x is 0. If x is 0, that whole thing is 0, which means this whole thing up above is 0. 3x plus 1, we're going to subtract 1 from both sides. And then we're going to divide both sides by 3. And then x minus 5, we're going to add 5 to both sides. We get x equals 5. And all 3 of those are valid solutions, and it's completely acceptable that we have more solutions this time. In fact, you don't have to memorize this, but this is the highest power here is 4th degree, so we'll have up to 4 solutions. We won't always get 4. Basically here, this is almost like a repeated solution, because we could have thought about that as x times x and split it up into x equals 0 for the first one and x equals 0 for the second one. So it kind of counts as 2. But 3 solutions is great. We definitely can have 3 solutions here, and there's not a problem with that. Okay, so we can extend this out to higher degree polynomials. They don't just have to be quadratic. This actually still works if it's a third degree that's factorable or a fourth degree that's factorable. Anything you can factor, this trick works on. Okay, thanks for watching.